Hello friends, in this video I'll explain you the concept of line balancing with the help of an example. Firstly, we will understand what is line balancing. Generally, in any organization where manufacturing type of processes are taken place, in that generally we have so many jobs. In case of line balancing, when we have to assign jobs to workstation, what a person can do or what a manager can do, he or she can divide the jobs into the work elements. Like suppose in any particular organization, there are three jobs, job 1, job 2 and job 3. These can be divided into the work elements. Work elements are the smallest units which cannot be divisible further. So in that way, generally one labor or one person and one machinery is required to do this particular work element. But one work element can be done by the or can be assigned to the one worker and the one machine. But one worker and one machine can perform more than one work elements. So this way in line balancing generally the work elements are grouped and they are assigned to workstations. And the purpose of assigning these tasks or these work elements to workstation is we need to try to do or we need to try to equalize the time of the each and every workstations. So this is the concept behind line balancing. Now further we will understand this thing with the help of an example. Before that, we will see few formulae which will be used for the line balancing process. So firstly, we need to calculate the desired cycle time. The formula is production time available divided by desired units of outputs. This way we can get desired cycle time. Afterward, we need to calculate N. N is the theoretical number of workstations or the minimum number of workstations. So for that, whatever work elements or whatever tasks are given in the question, we need to add all the times of those tasks, and that summation of the time will be divided by the desired cycle time. And that way we will get the minimum number of workstations. E stands for efficiency, and to get the efficiency the formula is we need to add all the task time and that we will divide by the N into CA. N is the actual number of workstations and CA is the actual cycle time. So actual cycle time is what? It is the maximum workstation time. Then balance delay, it is 1 minus efficiency, and idle time is NC minus summation of T. So that way we can get different formulae to solve the problem of line balancing. So I am taking one example here. Here we are given with that there is a real fruit snack strips are made from a mixture of dried fruit, fruit coloring, preservatives and glucose. The mixture is processed out into a thin sheet, imprinted with various shapes, rolled and packaged. The precedence and time requirement for each step in the assembly process are given below. To meet demand, real fruit needs to produce 6,000 food strips every 40 hours week. Design an assembly line with the fewest number of workstations that will achieve the production quota without violating precedence constraint. So here we are given the table, in that we are given with the 4 tasks and their description. And the precedence for these 4 tasks is given in the third column, and this is the processing time for all the 4 tasks, which is in the minute. Now with the help of this information, we will calculate the cycle time, then we will find the minimum number of workstations, and then we will allocate these work elements or these tasks to the workstation so that we can see what will be the efficiency of the line balancing. So firstly, we need to draw the precedence diagram. So here we can see for the task A, there is no precedence. That means your diagram will start from the A. So on the first node, we are writing A. Then for B, the precedence is A. That means from A, we are take out B, like this. Similarly, for C, the precedence is A. So from A, again, we are take out C. And then from B and C, we have to take out D, because for D, the precedence are B and C. So like this. So this way we have made our precedence diagram. Now we need to keep the time on each of the node for these work elements or the task, like this. After making the precedence diagram, now we need to calculate the cycle time. So for cycle time, this is the formula, and for these two things, the information is given in the question. Production time available, it was given 40 hours week. So we are converting this hours, or we are converting hours into the minutes, because task time is given into the minutes. So that is why we need to calculate cycle time into the minutes. So it is 40 hours into 60 minutes per hour divided by 6000 units. So that way we will get 2400 divided by 6000, or it is 0.4 minutes. So this is the cycle time value, or this is the desired cycle time. Now we will calculate the minimum number of workstations. For that we need to add all the task time, that is all these 4 task time is 0.1, 0.2, 0.4 and 0.3. So we are adding that, and that we are dividing by the cycle time or the desired cycle time, which we have calculated in the first step. So this way we will get the workstations, 2.5 workstations. Workstations cannot be in the decimal point, so we can round off and we can write. We need to we need to design minimum 3 workstations. Now further what we need to do, we need to allocate 4 tasks into the 3 workstations. So now in this table we will understand we have to make 3 workstations, which we have calculated here. Now for first workstation we are available with the 2 tasks, that is A and B. For A the processing time is 0.1, for B the processing time is 0.2. So if we are allocating first task, that is A, to first workstation, so the remaining time would be 0.3, and the remaining tasks are B, C and D. So next we are taking B, and for B processing time is 0.2. So now remaining time for first workstation is 0.1, means 0.3 minus 0.2 will give us 0.1, and the maximum time which we need to allot for each workstation is this cycle time, that is 0.4. So that is why the sum of these work elements which we are allocating to the workstations, that cannot exceed this 0.4. It can be either equal or less than. So we can see the sum of A and B processing time is 0.3. So still 0.1 is remaining for the workstation 1. So that would become the idle time for workstation 1, because we cannot take the third task here, because for third task, that is C, the processing time is 0.4 and which is greater than 0.1. So we cannot allocate C in the first workstation. So now for that we are moving for the second workstation. Here we are allocating next work element, that is C, and now there would be no remaining time, because highest time or the maximum time which we are allocating for workstation is 0.4, and C is also requiring for 0.4 minute to complete. So that is why the remaining time would be 0, or the idle time for workstation 2 would be 0. And now we are only left with the last task, that is the D. So that we will allocate in the next workstation, that is D. And to complete D, we are requiring 0.3 minutes, or the processing time for task D is 0.3. So this way the remaining time would be for workstation 3 would be 0.1. So that way we can allocate these tasks to the workstations. Now further we need to show this grouping of the work elements in the precedence diagram also. So here we can see we have grouped A and B into the first workstation, C is in the second workstation, and D is in the third workstation. So that way we have designed total 3 workstations in the layout, and we are writing here for A and B, or that is for workstation 1, the total time completion time is 0.3, for workstation 2 it's 0.4, and for workstation 3 time is 0.3 minutes. Now we need to calculate the efficiency. Formula is the summation of the task time, which we need to divide by the N into CA. N is the actual number of workstations and C is the actual workstation time, or that is the maximum workstation time. So now we are putting here all these values in the numerator and denominator. So here you can see N is the actual number of workstations. So actually we have designed total 3 workstations. That is why N would be 3. And CA is the maximum workstation time. So here we can see maximum workstation time is 0.4. So that is why we have written here into 0.4. Now we can solve this and can write this as 1 divided by 1.2. That would give us 0.833, or we can say 83.3% is the efficiency of the line or the assembly line. So thank you friends for watching this video. Kindly subscribe my channel Dr. Chanchal Jain. Also please like, share and comment on my videos. Thank you. Happy learning to all.